everyone, welcome to CodeQuest, where we make learning information technology fun and easy.
Today, we're diving into two powerful algorithms used in graph theory, Dijkstra algorithm and Prim's algorithm.
We're going to explain their steps, show detailed demonstrations, and highlight how they're used in the real world.
So grab a notebook
And let's jump right in.
Let's start with Dijkstra algorithm. It's used to find the shortest path from a starting node to all other nodes in a graph. This algorithm was developed by Dijkstra in 1956 and is a perfect example of a greedy algorithm where we optimize locally at every step to find this global solution. Imagine planning a trip from your home to multiple destinations and you want to minimize your travel time. Dijkstra algorithm helps to find the fastest route by systematically comparing all possible paths.
Here's how it works. First, assign a tentative distance to all nodes, 0 for the starting node and infinity for all others. Second, visit the unvisited node with the smallest distance. Third, update the distances of its neighboring nodes using the formula. Distance of v is modified to distance of u plus cost of an edge u, v, where distance of u is the current distance and cost of an edge u, v is the cost of the edge. Fourth, mark the current node as visited and move to the next unvisited node with the smallest distance. Fifth, repeat until all nodes have been visited. Step 1. Start at node A. Distance to A itself is 0. Distance to every other node, B, C, D, E, is infinity because we don't know how to get there yet. Step 2. Visit neighbors of A. From A, we update the distances to the nodes directly connected to A. A to B is equal to 7. A to E is equal to 1. Now, we update the table. Step 3. Visit the closest nodes, E. The closest node to A is E. Distance is equal to 1. From E, we update the distances to its neighbors. E to C is equal to 1 plus 2 is equal to 3. E to D is equal to 1 plus 7 is equal to 8. Now, the table looks like this. Step 4. Visit the next closest node. The next closest node is C. Distance is equal to 3. From C, we update the distances to its neighbors. C to D is equal to 3 plus 6 equals 9. But the current distance to D is already 8, which is shorter, so we don't update it. The table remains the same. Step 5. Visit the next closest node. The next closest node is B. Distance is equal to 7. From B, we update the distances to its neighbors. B to C is equal to 7 plus 3 equals 10. Current distance to C is 3, so no update. B to E is equal to 7 plus 8 equals 15. Current distance to E is 1, so no update. The table remains unchanged. Step 6. Visit the last node. The last node is D. Distance is equal to 8. From D, there are no shorter paths to update. This is the shortest distance from A to every other node. To B, A to B is equal to 7. To C, A to E and C is equals to 3. To D, A to E and D is equals to 8. To E, A to E is equal to 1.
So our topic for today is about Dijkstra algorithm, which is disadvantages and advantages. First is we need to know what is the advantages of Dijkstra algorithm. For short, it is used for Google Maps and others. One of the examples is Google Maps. It gives us the shortest path in the maps, which is example, we need to go in the other place, and then it shows us shortest path and shortest time to travel within. And then the disadvantages of that is time consuming to the computer, because you need to travel each of the node before you get the shortest path, and it cannot handle negative edges. For example, you have a shortest path, but you need to travel in the mountain, and then that is, and for sure the disadvantages and disadvantages. Advantages is gives you a shortest path, but the disadvantages is it cannot handle negative edges and time consuming. Thank you.
Now let's switch gears to frame algorithm. While Dijkstra finds the shortest path, frame focuses on building a minimum spanning tree, or MST. A minimum spanning tree connects all the nodes in graph with the smallest total edge weight without forming any cycles. Prim's algorithm was originally developed by Dijkstra in 1930, rediscovered by Robert Prim in 1957, and refined by Dijkstra in 1959. It's another example of greedy algorithm.
Now let's break down how Prim's algorithm works step by step. First, start with any node. This is completely arbitrary, so pick your favorite. Let's start with node A. Second, add the smallest edge connected to your tree. From A, we'll choose the edge with the smallest weight. Third, keep growing your tree. Each time, connect a new node using the smallest edge that links to your tree. Fourth, avoid cycles. If adding an edge would form a loop, skip it and move to the next smallest edge. And you're done when all the nodes are included in your tree. Consider the following graph as an example for which we need to find the minimum spanning tree, or MST. Step 1. You will choose an arbitrary starting vertex. Let's say node A is your starting vertex. This means it will be included first in your tree structure. Step 2. After the inclusion of node A, you will look into the connected edges going outward from node A, and you will pick the one with a minimum edge weight to include it in your tree consisting of the vertex set V and the edge set E. Structure. Step 3. Now you have reached node B from node B. There are two possible edges out of which edge BD has the least edge weight value, so you will include it in your MST. Step 4. From node D, you only have one edge, so you will include it in your MST. Further, you have node H, for which you have two incident edges. Out of those two edges, edge HI has the least cost, so you will include it in MST structure. Step 5. Similarly, the inclusion of nodes G and E will happen in MST. Step 6. After that, nodes E and C will get included. Now, from node C, you have two incident edges. Edge CA has the tiniest edge weight, but its inclusion will create a cycle in A3 structure, which you cannot allow. Thus, we will discard edge CA as shown in the image below. Step 7, and we will include edge CF in this minimum spanning tree structure. The summation of all the edge weights in MST tree consisting of the vertex set V and the edge set E is equal to 30, which is the least possible edge weight for any possible spanning tree structure for this particular graph.
Prim's algorithm is widely used in network design, building cost-effective road, rail, or communication network, electric grids, optimizing power distribution system, clustering, group data, and machine learning. It's simple and efficient for a small graphs, but it can become slower for evidence graphs.
Let us know in the comment what topics you want us to cover next. And remember, learning algorithms is all about practice. Keep at it.
That is for today. We hope these detailed demonstrations made the concept clear.
So next time
hit
on
the
Conquest.
subscribe button
Bye!
and share with video with your